Hello everybody, welcome back to our embedded system development video series. And in the previous video, we looked at the overall design workflow, and the first thing that we talked about was the requirement analysis. That is why today's video we are going to pick the first one, requirement analysis, and dig deeper using our own project. Now, I want you guys to take a look at the presentation right here. We are going to design an automatic hot chocolate dispenser. By the way, it works for coffee. It doesn't really matter. And I want this to be a portable machine that prepares hot chocolate without manual mixing. It's going to do all the mixing, all the heating. The system is made up of a few key components. At the top right here, we have separate funnels for chocolate pellets, sugar pellets, and milk. Now, all the ingredients that we'll be using for this machine has to be in the form of pellets. And the reason is we are going to use an auger feeder. So as the auger feeder rotates, it will pick the items one by one and drag them into the mixing chamber. Right behind, you can see the outside is glass, right? We have our water heating chamber and also mixing chamber. The mixing chamber is at the bottom and the water heating chamber is on top. And the reason is I'm not going to use pump to draw out the heated water and send it into the mixing chamber. In this design, I want to employ the help of gravity. I've placed the heating chamber on top. When the water is done heating, a valve will open and the hot water will drain straight away into the mixing chamber. There will be a pipe right there. When you look at the cross-section view right here, you can see a space. That space is going to house the electronics, and in this project I'm going to use ESP32 because we will need to connect to Wi-Fi and probably Bluetooth. In this space we will have the batteries, we have the motors for actuations, the wires and the connections. The cross-section view gives us a clear insight, like the four funnels for the ingredients that we are going to use. Each item will be put into one funnel. Function wise, this machine can dispense ingredients automatically using an auger feeder mechanism. What will happen is we will heat water in the temperature chamber and the items will be picked up from the funnels and transported into the mixing chamber. When the water is done heating, it will be moved by means of gravity into the mixing chamber and everything will be mixed inside the chamber. When it's done mixing, we can retrieve our hot chocolate right through a pipe into the nozzle, which will be positioned in front of this. This cavity is for the cup that you are going to use. The good thing is that the user can control the drink configuration using two methods. I'm considering a mobile app and connecting to the ESP32 via Wi-Fi communication. And also, I will make a physical LCD and keypad and attach it either on top of this or right here at the center so that a user can also make his selection right from the keypad. This is the product that we are going to use to break down the requirement analysis step by step. Let's do this. The first question is from the slide, what is requirement analysis? Now, I have made 3 points right there. This is where all the ideas become clear, it's structured and is measurable. Now, this is the phase where we want to prevent redesigns, right? We want to prevent confusion in the future and we want to prevent expensive mistakes later. We are not building the hardware yet. We are simply defining what we want to build, right? A few questions that you would like to ask will be one, what exactly should the system do? With this question, we mean define the capabilities of the system. The second question will be, what constraints do we have? And now you are thinking about power, you are thinking about size, you are thinking about cost, and you are thinking about materials. You get it. The last question that I would ask myself as I'm going to build this project will be, what performance levels am I aiming for? And this includes the speed, the accuracy, and safety. Clearly, if you look at the product that we want to build, it's going to heat up water, it's going to draw some ingredients, it will mix them up, and then the user or the consumer in this case can just press a button and draw some hot chocolate, right? Which means that you want to consider some safety things, right? You don't want the system to overheat or burn, which means that requirement analysis allows us to kind of sieve our idea right here. We have a lot of ideas going around in our head. We sieve it until we get the ideal knowledge of what we want to build. We want to build automatic hot chocolate dispenser. Now, with the functional requirements, we are defining the core capabilities the system must provide. This is product specific. And without these things, we know that the product has failed its purpose. After making this product and it cannot heat water, it cannot mix up the ingredient, then we failed. We need to reconsider some things again. With dispensing, I mean that the capacity to store each ingredient that we will need to mix up our chocolate, the milk, the sugar, and other extra items of flavor that you would like to add. And this is going to directly interact with the Auger feeder mechanism. We move to the mixing and the heating. First of all, the ingredients have to be transported into the mixing chamber, right? Now we will heat water to a specific temperature inside the heating chamber, and then we will transport the water into the mixing chamber. In our design, we know that we are going to use gravity. We are excluding pump, which means that we must pay close attention to the design's height and flow. If you need the help of gravity, you should consider height. The next point is the user interaction, and with this dispenser, we will allow the user to input via mobile application or by directly typing on the keypad and LCD that is attached to our automatic dispenser. With configurability, we want this automatic dispenser to prepare the drink based on the parameters that the user will set when he wants it to start. You can set a timer at which you want the chocolate to begin. By the time you get home, you still have a hot chocolate. The number of cups that you want your machine to prepare, and this is limited by the water holding capacity of our product. The final product will be to dispense the hot chocolate or drink or coffee through an output nozzle. Just as important as the functional requirements, we have the non-functional requirements, and this is going to define the quality, the performance, and also the user experience, right? There is a big difference and a huge gap between having a working prototype and a reliable product, and this is what is being defined in the non-functional requirements. In this design, first we will look at the response time, right? Which means that our product should respond to the user command within 1 to 2 seconds. You don't want to give a command, for example, start preparing the chocolate, and the product takes too long to prepare. Also, we are concerned about the temperature accuracy because we are going to heat water, right? We don't want overheating and we don't want burning, which means that the heating element must maintain accurate temperature reading. Maybe plus or minus 2 degrees should be fine. Power use and portability. If I really want this to be portable, then probably I'm going to run it on a battery, right? Which means that the system should run efficiently on a rechargeable battery and be compact and lightweight for easy carrying, which means that this could serve a few people at a time, let's say 3 persons at a time. And the last point of the non-functional requirement will be safety and safety again. The system must include an automatic shutdown when overheating is detected. This is crucial because it can lead to overheating and burning of our product completely, and we don't want that. The next important thing that we have to consider is the constraint. And since we are building a physical product, we need to pay attention to all the physical and mechanical constraints, right? Now, on the slide is a functional diagram of the same product that I showed here. This is the 3D designs, but in terms of function, we have something like this. The water chamber, as you can see on top here, it must be positioned above the mixing chamber to enable gravity flow of the water. Also, we need to make sure that our funnel is not being clogged by the ingredients. That is the main reason we are not using powdered form of the ingredients, but we are going to use pellets. The base of our device is going to house the ESP32, all our electronics, and the batteries. In terms of the firmware development, we are going to be guided by our own software requirements, right? We already know we are going to use ESP32 to build this, which means that we should be able to handle all the motor control for the Auger feeders. 4 Auger feeders, right? Each for the compartment that is going to house the ingredients. We are going to have a temperature sensor to make sure that we are not overheating our system, and we will have a heater control to enable us to heat the water to temperature that we want. The next is the Bluetooth and or Wi-Fi communication, because we want to allow the user to be able to set the parameters and also start or stop the device from a mobile application. We need to consider the constraints of Wi-Fi and Bluetooth communication. And in case the user wants to go the manual route by typing in his command via the keypad which is tagged to the device, we need to make sure we are giving the user a good user interface, right? Probably you might be asking this question: why requirement analysis matters? The analysis part is the most crucial part because you are literally setting up the boundaries for your product. Skipping this part tends to be costly in the long run, and you cannot even optimize a product that you have not defined well. It ensures that you choose the correct microcontroller and sensors, right? One importance of making requirement analysis, it serves like a plan kind of. So once you have the plan and you have everything defined, you will actually notice how fast you can go. It gives you clear goal. It means fewer unknowns. You know most of the variables that you are going to deal with, and it leads to like faster development and no wasted components or redesigns in the long run. Now, to conclude, the tools and what we have talked about is more like a documentation of how I'm going to build this automatic hot chocolate dispenser and the conceptual design, right? So for this dispenser, I have used ESP32 for wireless control. Also, I'm going to use LCD or keypad for the UI, which is going to be faced to the device itself, and the auger feeder for feeder mechanism, that is extracting our ingredients and transporting them into the mixing chamber. I also designed our card model using Fusion 360. I'm doing this to give you an example, right? This is how requirement analysis breaks down an idea into clear buildable components. Now, in the next video in the series, we are going to dive deeper into the system design and architecture, where we will convert these requirements into block diagrams and hardware modules and communication flow, and see how the system will communicate with each other, which output is going to serve as an input for what, and how our embedded system architecture will come together to help us design this automatic chocolate dispenser. I'm going to build this product with you and show you each step along the way. My goal for you by means of making this video is that at the end, it's my greatest desire that you will be able to come up with an idea, make the requirements for it, make your architecture for it, and build your product in hand. This is what embedded system development is all about. See you in the next video.